Bismillahirrahmanirrahim. Our next topic name is find the solution by Cramers rule. This method we use to solve the system of linear equations. First we take a question that we use in which we use the Cramers rule to find its solution. That is our exercise number 3.2, page number 104. Let I take question number 1. Its statement is 3x minus 2y is equal to 7. Then 2x plus 4y is equal to 10. In this Cramers method, we have to convert the given system of equations in a matrix form. So we write here the system of equations in matrix form in this way. First, in this matrix, I write down the coefficients of these, the coefficients of the variables. Here it is 3, then minus 2, then 2, then 4. Then I write another matrix that is based on the variable, that is x and y, equals to, I write another matrix which contain the solution of the equations, that is 7 and 10. We name it the first matrix as we find that this matrix contain the coefficients of the equations or the variables, so we name it coefficient matrix. This matrix is called unknown matrix or the matrix of unknown. And this is called because this matrix contains the solution, so it is called the solution matrix. Now we name it the coefficient matrix. We say this is called A, and the unknown matrix, it is called X, and the solution matrix name is, let's say this is B, and we write this, so we get an equation A x is equal to B. Ax is equal to B. Here we have to solve. We have a specific procedure to obtain the solution. Here A is the coefficient matrix. First we find out this matrix is singular or non-singular. Before this we calculate its determinant. First we know that what is singular and what is non-singular. Singular mean if determinant of a matrix is equal to 0, that matrix is called singular. Whenever if matrix is singular, its solution does not exist. Now we see number 1, number 2, non-singular matrix. If the determinant of a matrix is not 0, such a matrix is called non-singular matrix. And in this case we conclude its solution. Now we see that what is determinant. Here we have a coefficient matrix. Let A is equal to this 3 minus 2 2 4. It is up to you if you like to draw such type of parentheses, or you use a square bracket. It is up to you. Now we find its determinant. Determinant is defined as, it is written in a two vertical line, in between a two vertical lines, and the system again 3 minus 2 and 2 4. It has two parts. One is called this, which I am shading. This is called the diagonal, and the other is called the secondary diagonal. This is called the main diagonal. This is called main diagonal, and the other one is called, this is called secondary diagonal. So how we can evaluate this? We evaluate this by multiplying. First we multiply the elements of main diagonal elements. 3 into 4, then negative, then we multiply the elements of secondary diagonal 2. So determinant is equal to, you have to multiply the main diagonal elements and then operation sign, that is negative, and then you multiply the secondary diagonal elements. Here you solve this. 3 4 12, 4 2 2s are, this is minus 2, sorry, 2 2s are 4, minus 4 minus minus plus, that is plus 4. When you add up these, you get 16, which is not equal to 0. So it is a non-singular. It is a not singular matrix. And now we say that because it is non-singular matrix, as it is a non-singular matrix, so we are able to solve it further and find its solution. Now we see this. It is a non-singular matrix. So we have to find the value of x and y. We find here one determinant for x and one determinant for y. And its procedure is like this. Determinant of x. Determinant of x. And how I can write this? As you see here, this first column 3, 2, the first column 3, 2 are the coefficients of x, are the coefficient of x. You simply do this. You have to replace this x column with this 7 and 10, which is the solution matrix. You have to replace the x column with solution matrix, that is 7, 10. Now you replace this, that is 7, 10, and the second column remains same, that is minus 2, 4, minus 2, 4. Now again you find its determinant. You have to multiply the main diagonal elements, then operation sign negative, then you multiply the secondary diagonal element, 10 and minus 2. 7 4s are 28, minus plus 10, 20. This is equal to 48. Now we find similarly the determinant of elements of y. Determinants of elements of y. Here you write in this way. Now we find the determinant of elements of y. You write down the x column as it is. At this time you replace the y column with the solution matrix. So you write here 7, 10. You write here 7, 10. Again you evaluate this. This is equal to, then you multiply the main diagonal elements 3, 10, then operation sign, and then the secondary diagonal elements product. 30 minus 2 7s 14. This is equal to 16. Now we find the value of x and y, and its formula is, if you find the value of x, you have to do simply do this. You divide the determinant of x by the matrix coefficient matrix determinant. Similarly, when you find the value of y, you simply divide the determinant of y by determinant of coefficient matrix. Here dx is equal to, as you see that is equal to 48, and the value of the determinant we find it, that is 16. Here you see that it is 16. Then y is equal to, here the determinant of y is equal to 16 divided by determinant of a, that is equal to 16. When you simplify this, you see here 16 3s are 48 and y is equal to 1. So our answer is, solution set is 3, 1. In this way, it is another technique through which we solve our system of linear equations. The first method that we see through which we find the solution, that is graphical method. The second one is the elimination method, and the third one is now the Cramers rule. Now we take another example in the form of a question. It is question number 2. I write its statement. that is 2x plus 4y is equal to minus 16. Then x minus 2y is equal to 16. Again we write it in a matrix form. If we write it matrix form, first matrix, in a first matrix we write their coefficients. Its coefficient is 2, then 4, then 1, then minus 2. It becomes our coefficient matrix. Then the matrix of variable. When you multiply both these, we again get the same equations, is equal to the solution matrix, minus 16 and 16. We name it this A, the coefficient matrix, and the matrix of variable, it is called X, and the solution matrix name is B. So we write it in a equation form, AX is equal to B. Now we find either the solution of this system is possible or not. How we can find this? We find it by finding its determinant value. If determinant value is 0, then its solution not possible. If its determinant value is non-zero, then its solution possible. Let's say A is equal to what? This is equal to 2, 1, 4, minus 2. Now we take its determinant. This implies that determinant of A is equal to determinant of the values 1, 4, minus 2, 2. How you can compute this determinant? By multiplying the main diagonal elements, then operation sign negative, and the secondary diagonal elements. Here it is minus 4 and minus 4. This is equal to minus 8, which is not equal 0. So its solution possible. Okay. Now we see that now we find the determinant of x elements. We find the determinant of x elements, in which we replace the x element, x column. Here you see the x column replaced with this solution matrix. So we write here minus 16 plus 16 and the value of the y column, that is 4 minus 2. Now you simplify this. Minus 16 is multiplied with minus 2, then operation sign negative, then 16 multiplied by 4. 16 2s are 32, 16 4s are 64. So it is equal to minus 32. Now we find the determinant of y values. In this we write the x column as it is, that is 2, 1, and the y column is replaced by the solution matrix, that is minus 16 and 16. Now you simplify this. 2 multiplied by 16 minus operation sign, then 1 into minus 16, 32 plus 16, this is equal to 48. Now we find the values of the x and y. X is equal to, how you can find this? By dividing the determinant of x values divided by the determinant A, and the value of y can be found as by dividing the determinant of y values divided by A determinant. So the determinant of x values is equal to minus 32 divided by minus 8. Y is equal to, the value of dy is equal to 48 divided by determinant of A is equal to minus 8. Now you simplify this. 8 4s are 32 and y is equal to 8 6 are. So our solution is 4 minus 6. In this way, you can solve a system of 2 by 2 equations. And now you are able to find all the solutions by this method. You only attempt the odd questions. Only attempt the odd question. If you feel any problem, then you tell me in a class, in a classroom. So inshallah ta'ala I will explain you. Okay, Allah Hafiz.